Okay, so we were continuing with the last part of section 9.3, where we're talking about writing net ionic equations using the rules of solubility. All right, so you have a reaction between barium nitrate. All right, so barium nitrate, separate out the ions, it's soluble. Both barium ions and nitrate ions are soluble. And then sodium carbonate, again, sodium ions are soluble, and so are the carbonate ions, right? However, when barium and the carbonate ions, barium ions and the carbonate ions come together, they become insoluble, all right? So the spectator ions are the nitrate and the sodium ions, all right? If you get rid of them, what you're left is the formation of the solid, the net ionic equation, which is barium and the carbonate coming together, forming barium carbonate, all right? So this is how you use the solubility rules and determine what the net ionic equation is, all right? The ionic equation is where you write out the entire thing, all right? And then if you go back one more slide backwards, oh, sorry. When you write like this, this is called as a molecular equation because of the fact that you're not separating out the ions. When you separate out the ions into the positive ions and the negative ions, that's only when you see the AQ, all right? And so that part is called as the ionic equation, which is the complete ionic equation, okay? So this would be called the complete ionic equation, and then the net is just the formation of the solid. All right, moving on to section 9.4, how do we determine the concentrations of solutions? There are several ways. One is where you measure out the amount of solute and add it to a measured amount of solvent, all right? So for example, here, if you take 8 grams of the potassium iodide, the solute, and add it to 42 grams of water, or roughly 42 mils of water, because the density of water is 1 gram per mil, then the total mass of the solute plus a solvent would be 58 plus 42, all right? So the grams of solute divided by the grams of solution times 100, that will give you a percentage mass by mass, all right? You can have percentage mass by volume, or you can have percentage volume by volume for liquid solutions, or another type of solution is called as molarity, which is moles per liter, right? So we'll look at all of them. So you can have a mass percent solution, percentage m by m, small m, where the solute and the solution are in grams. Now remember, the solution includes the grams of solute plus the grams of solvent. Together they make the solution, all right? Or you can have a percentage volume by volume, where both the solute and the solutions are in mils. Or you can have a percentage mass by volume, m by v, where the solute is in grams but the solution is in mils. Or you can have molarity, which is moles of solute per liter of solution. So amount of solute in a given amount of solution, that's the concentration, all right? This amount can be in grams, it can be in mils, or it can be in moles, all right? Again, the amount of solution can be in grams or mils or liters. Okay. So an Percentage m by m is a mass of the solute and mass of the solution, which means that includes mass of solute plus the mass of the solvent, all right, times 100%. So that would be a percentage mass by mass. So here, going back to the example of the potassium chloride, if you have 8 grams of potassium chloride and 42 grams of water, all right, so you initially weigh out your 8 grams and add enough water till the mass goes up on the scale to 50, all right. So 8 divided by 50 times 100, and that's a 16% mass by mass potassium chloride solution. All right. What you can then do is use these expressions in problem solving. All right. Okay. You can use the mass by mass as an equivalency and then calculate either the amount of solute or the amount of solution. So for example, it says in this particular study check, you have 30 grams of sodium hydroxide and 120 grams of water. What is the mass percentage of this sodium hydroxide solution? All right, the solute, the lesser amount is the sodium hydroxide, 30 grams. The solvent, the larger amount is water. So 30 plus 120, that's 150, all right. So 30 divided by 150 times 100, that would give you your mass percentage, all right, and that comes out to be 20% mass by mass. All right, a solution is prepared by mixing 15 grams of the sodium carbonate and 235 grams of water, right? So solute is the 15 grams. The solution is 15 plus 235, that's 250 grams, right? So 15 divided by 250 times 100, all right? So that should come out to be 6%. And then you have a percentage volume by volume, which is mils of the solute by volume of solution, all right? So times 100, okay? So that's, again, you can use this as a conversion factor where you can either determine the mils of solution or the mils of solute. And then you have the mass by volume where you have a solid in a liquid. So it's grams of the solute in 100 mils of solution. So it says write two conversion factors for each. 8.50% mass by mass, that sodium hydroxide. That means it's 8.50 grams of sodium hydroxide in 100 grams of solution, or vice versa, 100 grams of solution over 8.5 grams of sodium hydroxide. 5.75% volume by volume ethanol. So that means it's 5.75 mils of ethanol in 100 mils of solution, and vice versa. 4.8% mass by volume HCl. So that's 4.8 grams in 100 8 grams of HCl in 100 mils of water, or solution rather, okay, and vice versa. So this is how it would come out to look like: 8.5 grams of sodium hydroxide, 100 grams of solution, or 100 grams of solution by 8.5 grams of sodium hydroxide. And then for the second one, 5.75 mils of ethanol divided by 100 mils of solution, or 100 mils of solution divided by 5.75 mils of ethanol. Gram by volume, that's 4.8 grams of HCl by 100 mils of solution, and vice versa. All right, then you have the last type of solution, which is a molarity, which is moles of solute in liter of solution. That's the definition of molarity, and it's given the symbol big M, M. All right, so M means moles per liter. So here you see a mole of sodium chloride. Now, of course, you're not going to be weighing out or counting out a mole of sodium chloride. You know that a mole of sodium chloride, the molar mass is around 58.45 grams. So you'd weigh out 58.45 grams, add it to a volumetric flask, and then add enough water to make it up to the 1 liter mark. And now you have a 1 molar solution, a 1M solution of sodium chloride. All right, so it says in this particular study check, you have a half a liter of sodium hydroxide. What is its molarity if it contains 6 grams of sodium hydroxide? So the first thing is molarity is moles per liter, right? Okay, so you have the volume, that's half a liter, but you have to convert the 6 grams to moles, all right? So the molar mass of sodium hydroxide is 40. So divide the 6 by 40, that gives you the moles. Once you have the moles, then divide the moles by the half a liter to get your answer in moles per liter, okay? So 6 divided by 40, that's 0.150 moles of sodium hydroxide. Now take 0.150 moles of sodium hydroxide and divide it by 0.5 liters, and that would give you the molarity, which is 0.3 molar sodium hydroxide. So in this study check, it says, what is the molarity of 0.225 liters of potassium nitrate solution containing 34.8 grams of potassium nitrate? Again, take the molar mass of potassium nitrate, divide 34.8 by the molar mass of potassium nitrate, and you get the number of moles. Once you have the moles, divide it by 0.225 liters, and you get moles per liter or molarity. Okay, so 101.10, that's the molar mass. So 34.8 divided by 101.10, and you get 0.344 moles, and then you divide it by the liters and you get moles per liter, which is M, or molarity, 1.53 M, and so that's B. Okay, so you can use molarity as a conversion factor, moles over liters or liters over mole. So in all of these cases, you can use either the percentage concentration or the molarity as conversion factors, all right? Gram of solute over gram of solution, or vice versa, mil of solute over mil of solution, gram of solute over mil of solution, or moles over liters, and so on. All right, so you look at what's given, write out a plan where you can convert the given into the needed quantity using those equalities and conversion factors. So here it says how many grams of sodium hydroxide are needed to prepare 70 grams of solution, which is 14% mass by mass, all right? So 14% mass by mass means that you have 14 grams of sodium hydroxide in a 100-gram solution, all right? So 75 times 14 divided by 100, and that should give you the equivalent grams of sodium hydroxide, okay? And I apologize again, it's annoying, sorry. So that comes out to be 10.5 grams of sodium hydroxide, and that's A. So in the next problem, it says how many grams of aluminum chloride are needed. Let's just stop here.